Hello everyone. In this video, I will be solving GATE 2020 question set for chemistry, question number 40. It carry 2 mark. So this question state that the correct voltage E versus time excitation signal used in the cyclic voltammetry is. We are provided with 4 different options, but before we end up with one correct, we have to go with some basics. So the definition for cyclic voltammetry is an electrochemical technique which measure the current that develops in an electrochemical cell under conditions where voltage is in excess of that predicted by the Nernst equation. CV is performed by cycling the potential of a working electrode and measuring the resulting current. To just break it into a simple form, so we have a potential state. This is an analytical instrument. It is designed to control the working electrode's potential in a multiple electrode electrochemical cell. Okay, so in cyclic voltammetry, we have 3 electrodes, working, counter, and reference, and that's why we use potential state for that. So this potential state apply a triangular form of potential to our electrochemical system. Okay, and then what we do, we measure the current versus time. But in this technique, the potential state apply a triangular potential waveform to an electrochemical system to measure the resulting current as shown here. The point to note here is that the triangular potential waveform is made up of potential sweeps. So you can see this is a linear potential, and then it's called segment 1, and then it sweeps to the potential which is again linear but in different fashion, meaning if it is positive, the other one is negative. So we are sweeping the potential linearly as a function of the time. So the measured current is also measured as a function of time as shown here. But finally, we plot the measured current here. This current as a function of the applied potential, which is here. So our applied potential, if it is in the form of the triangular wave function, and our current, which is measured with respect to time at first, they both are plotted together so that the plot that we get is what we call a cyclic voltammogram. Now, we have to get to the basic of the triangular potential wave function. So here on your right hand side, you can see potential versus time plot. Okay. So we have several parameters for this particular plot. The first one is the initial potential. It is the potential at the start of the experiment. Second is the switching potential, which defines the end of first segment. Final potential is the one which defines the second segment of our linear sweep, completing the triangular wave function. It completes one cycle in a cyclic voltammeter. And the fourth one is the sweep rate or scan rate. It's just the slope of the linear sweep. So what I have discussed here is shown in the picture as like this. This is the switching potential. This is segment 1, segment 2. And we have our final potential here. And of course, our initial potential. A cyclic voltmeter experiment, it may consist of one or multiple cycles. As for this example, we can see we have only one cycle. So the tip here is that the parameters of the triangular potential that we have discussed above and the number of segments can be adjusted depending upon our electrochemical system. The classical triangular potential waveform, this is the classical triangular potential waveform, but it is not strictly followed. The CV, the cyclic voltammetric experiment, must consist of at least two segments. Okay. Yeah, these are three different form of potentials that we can use in our CV, cyclic voltammetry. So other than the classical triangular form. Coming back to our question, where we were provided four different options, now you can just see that the voltage E versus time plot for the excitation signal that we get uh, to from our potential state, it should be okay. So the correct option is C. Okay, and the other three options are not correct for this because we are talking about cyclic voltammetry. And for example, A, this option is just the potential used in a linear sweep voltmeter. Okay. So I will just suggest you to go through the book Electrochemical Method Fundamental and Applications by Alan Bird and Larry Faulkner. And the NAPTEL reference is the lecture number 25 for the voltammetry and galvanostatic charge discharge by Professor Tamal Banerjee, Department of Chemical Engineering, IIT Guwahati. The link is provided here. I will also encourage you to go through this particular YouTube video link uh, for some helpful and interesting learning. Thank you.